Welcome back, dear friends. Oh, these aches and pains, they're getting better, thanks for your support, but they still just lurk around, and the bruising, I won't show you a picture, put you off your food for a week, once, sort of image that once you've seen you never forget, but the bruising is coming out. 2 weeks now. Anywho, on to more exciting things. Now, the last video I witted on about the wonderful new little stepper motor drivers that just take pulses, and I wired all 4 up, and I got all these 4 carriages and belts fitted, and it worked, but very slowly, using the acceleration stepper, Accel stepper library for the Arduino. So I've gone away and I've thought about it, and I read the instructions, who would have thought, and there's an example that comes with the Accel stepper library where it's got another separate library, which I will put up on the screen because I can't remember what it's called, but you add that to the standard library and then it allows you to group a load of stepper motors together in a block which is controlled by this new library, and they work beautifully. In fact, what it does, it's the same sort of stepper driver that I ended up writing, and don't get me wrong, it was so satisfying and rewarding to do it, for the Gregorian scribulator, where you've had the disc that turns round, you've got a scribe, magnetic scribe that moves this way and goes up and down, so you've got to coordinate the twisting and that, because obviously both, if you set 2 coordinates, an X and a Y for example, you want them to arrive at the same place at the same time. They all move at separate speeds, so they all arrive at the required points at the same time, which gives it a really nice look, and also it's brilliant. It's exactly what I want. I will show you, stop talking and show you. Oh, and the other thing I want to do this video, which I have been giving a lot of thought to, is actually how to play, well, that sounds good, doesn't it, notes. I've got to find a way of plucking and strumming the strings. I've got some ideas, so I'm going to experiment on that today as well. Right, let's get on with it. I'll demonstrate. Right, let's press reset on this because I don't want to reset and then quickly power on. There we are, right. Otherwise they go absolutely crashing into everything. So that's as it was before. So that's nice. Look, that's much faster. That's brilliant, and thank you to all the people who gave me advice on getting motors moving faster with the Arduino and alternatives to the Arduino. But that's as fast as the original was going, so I'm very, very pleased with that. Oh, by the way, the noise you can hear in the back of most of these videos is my beautiful 3D printer printing more of the motorised gauge enclosures. I bought a 1 kilogram reel of filament last week, and this beautiful poor thing, every time it finishes printing one that takes 5 hours 18 minutes, I peel it off and then start it printing another one. I get 2 done in a day. And these ones are 4. These, the ready-made version, is one that I opened up earlier, or the kit version. Something for everyone. And they really do sell very, very well. So I thought, while I'm getting on with other stuff, don't leave it to the last minute and suddenly realise you haven't got any left, because as I say, 5 hours 18 minutes per thing enclosure, plus then you've got to print all the gears and other bits and pieces and laser cut the panels and other gears and things. Do it now. So that's what that noise is. And these are stored in the lovely closing, very, very posh drawer. Probably won't close now. No, it won't. There we are. Look at that. Fabulous. I promise not to video every single thought that flickers through my mind. This is quite an exciting thought, because I was thinking about it last night when I couldn't sleep. Something uses a plectrum. Can you see what it is yet? It's not filament for 3D printing. It's flymo, or weed whacker in America, filament. I assume it's nylon, but look. Isn't that fantastic? I was doing some research on how a harpsichord works, and I mean, that would be brilliant. What a lovely chord. But look, that's fantastic. And that's quite soft. It's very soft actually. Soft nylon, possibly not even nylon, it didn't say, so I've got no idea. I know these are nylon because that's what the standard strings are made of. But that's fantastic, so it's not going to wear them out. Now I've got to work out how to move it. Stop doing that. I have some choices, dear friends. I have the first candidate, one of these lovely little stepper motors, but slow, but very, very quiet. Or, and I think this is what I'm going to try first, a solenoid. If I can work out how to get that to pluck a string and then to drop back, to try that. That's quite noisy actually. Sure about that. Or there's one of these little DC motors that I used to ring bells and strike chimes and things on other machines. It might be possible because they're very, very quiet, fast but quiet. Or there's a servo motor. The problem with servo motors, incredibly powerful, but they are so noisy. And if you've got 4 of something, every time you've got, oh hang on, that's the door. You beautifully get the chord or notes or whatever set up, and you have 4 of these whirring away. Don't know. Or an intriguing thing, harking back to the old Victorian mechanical music machines, they used bellows and a vacuum, I believe, to actually draw in and to move things. A beautiful examples, tons of them on the internet. It might be possible, and I would love to do it with these. Obviously they're quiet unless you've got a flute attached to them, and I could I don't know, I'm going to experiment with that as well. I'll get back to you when I have something more tangible in the ideas department. Well, idea number 1, start simple and just see what happens. There's the bellows. I've cut off the flute, sealed it with some blue tack, put a bit of pipe. So, me blowing on one end, there's a bit of the filament. Let's see what it does. Sort of, but it takes an awful lot of puff to move this, so I'll put that to one side. It would be lovely to use vacuum, but perhaps I can use it for something else. So this next idea, keeping everything as simple as possible at this stage, piece of wood, bit of filament. Now I quite like this one, and you've got the flexibility of the filament just doing all of the springiness, and it can move one side, and when it was playing the note again it could go back. Then I started thinking about having one of these motors rotating, possibly even some sort of wheel with one of the little filaments sticking down underneath it. That would have the effect of flicking past it. Problem with these, as I may have mentioned in the past, 4 outputs from the Arduino, one for each coil, and some sort of input for the micro switch or sensor that tells the Arduino where it is. Then I remember the little motors I use with the motorised gauges. They have one of these little motors on the back to drive everything. It hasn't got a pulley on, it just uses the spindle as a pulley to slow it down sufficiently to make everything work. And they are brilliant. They've got quite a lot of torque, obviously they go very fast, but they run on 3 volts and they last days, because the kit can come either, oh I feel some marketing coming on, with a 4 to 12 volt DC adapter converter circuit, so you can run it off a power supply, or a battery pack that holds 2 AA batteries. And when I've done shows in the past with these, they have happily run for days. And I did Lincoln a couple of years ago, pre-pandemic. I think it was several days, and they were running all the time, and the battery still had tons of juice in them. Anyway, perfect for steampunk outfits, costumes, and machines. 1,000 uses around the home. Or obviously, if you make your own one, you can colour it any colour you want. As always, I completely forgot to say, These and all sorts of other things are available on my shop, steamhead.co.uk, or my Etsy shop, which is steamhead something or other. Thank you very much. I must try and remember that. I think the whole idea of this is to actually sell exciting things to people. It's quite a useful thing to remember. Now, in the world of motors, stalling them is not a good idea. Stalling being just basically stopping them suddenly. When I've used them to run bells and things, they basically switch on for a second, lift up against gravity, and then just fall back. So they're not actually stalled as such. But I wondered whether they could be stalled. Something I've yet to try. There's no reason why they can't. If they receive a short enough pulse, then they can just spin around. So what I did, see, there's one there with focus. Hang on. Right, there's one there held in there. Where's my finger gone? Here it is. And you can see there's the little piece of wood just fitted down there onto the spindle. I've also put a screw underneath here so it can't go too far. It sort of acts like a stop. And I'm going to try it. But for the sake of you kind viewers, I'm going to use a tripod. That's better. Well, let's give it a go. Ooh! Now obviously I can't, I'm just switching it on and off from the power supply. But it works both ways. That is brilliant, and it's just stops, and if it's got a short enough pulse, it only needs enough to flow around. I'm really very excited by that. That's as loud as I've been able to get it with anything else, and I don't think the motors are going to mind. They may do. Now I could use an H-bridge to drive that. In fact, half with one of the H-bridge things for a 2-coil stepper motor, so I can get it to go one way and then the other way, and to stop. That's right. So when it starts up, it just needs to, yeah, that's okay. When you first switch it on, it makes all of them go either clockwise or anti-clockwise or something, and it remembers where they are, and it remembers which way the H-bridge was, and then next time it switches H-bridge, switches on and so forth. And I reckon I can get a strumming effect with 4 of those, one quickly after another in a sequence. I think it's lunchtime, and then this is really exciting. I keep using the word exciting. I'm sorry, I must look in a dictionary and learn some more. This is thrilling because it is so simple. That really is simple, and simple is good sometimes, and it can look lovely, and oh, that's very exciting. I will get back to you. It's after lunch, and wired up to one side of the H-bridge driver, which is also then in turn being driven by the 5 volts, 0 volts from the Arduino. That's just the logic side of it. But the motor side, this that controls, that sends the electricity off to the motor, is currently being run at 8 volts, which I think, if memory serves, is what I ended up running all these stepper motors at. So that'd be handy if I have an 8 volt thing there. But that motor is 3 volts. This is running at 8 volts. What to do? Well, what I ended up doing, because this has got an enable pin on each side. There's 2 of them for one motor, to one solenoid coil in a stepper motor. There's the other 2 connections for the other solenoid, other coil. Forgive my jumbling. And each side has got an enable pin. So what I've done is to connect the enable pin to a pulse width modulated output here. That means that regardless of which one of these is being switched on or anything else, the logic there is switching it on and off very fast depending on what the output from the Arduino is. So I can sort of in effect control the voltage, current, whatever that goes through the motor, sort of. This is what I'm going on about H-bridge controllers. This is what an H-bridge controller looks like in effect. There's plus volts, that would be the supply to the actual motor, so that would be 8 volts in this case. 0 volts all connected together as always, and then it's got 4 electronic switches that mean that if you switch that one on, the electricity goes that way through the motor and it goes one way. You switch them off and you switch that one on and that one on, the electricity goes that way and the motor goes in the other direction. How fabulous! If you switch that one on and that one on, it short circuits the power supply and blows everything up. Or equally that one. But these are power transistors or whatever, and they're controlled by logic gates to stop you doing that. And the enable thing pin basically just switches all of them, any that are on or off at the top. Any that are on at the time, on and off very quickly, in addition to being on, if that makes any sense. So that's how they work. And this, as I say, has got two. It's got one H bridge that side, one H bridge that side. And then stop talking and get on with it. So the other great thing about the Arduino is you can just comment out all the code you don't want. So this is still that first same sketch, but oh, where's something I've commented out? Oh well, there's 2 lines I've commented out. Anyway, I've left most of it in and just added a little bit. So here we are. Look, I've said here, pin mode, pin 11, output, pulse width modulated H bridge 1 and 2, and blah 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 blah. That's where I'm going to set it, the voltage that I sort of want. Then pin mode 12, H bridge in 2, H blah blah blah. So that controls the two the bridges each side of it. I've then said, okay, I'm going to start at about, I did try it less than this actually. I started about 100. It goes up to 255 with pulse width modulation. But it seems that the higher the better. I don't know how long the motor's going to last. 3-volt motor running on 8 volts, 230, which is sort of almost nearly all of it. Don't know. Then set the 2 outputs to low so that nothing happens with the motor. And then it cycles through here 20 times. It waits 0.1 seconds. Then switches one of the sides on high. Waits 150 milliseconds for the motor to actually have time to go over. Then switches off, waits another 0.1 seconds, and does the same for the other side of it. So it should go backwards and forwards. Shall we try it? Why isn't it going backwards and forwards? Let's have a think. Hang on. I know why it's not going backwards and forwards, because it's done its 20. Let's get it to do 20 more. There's the reset button on the Arduino. Fingers crossed. Oh, the joy! I really didn't know how I was going to do this. Well, I haven't known how I was going to do any of it. That's the dog yawning, waiting for her walk. This is fantastic. I'm so pleased. It's simple and effective. I'm just going to have to do that again. And as I say, I don't know how long this motor's going to last because it's running at almost 8 volts, but only for 0.15 seconds each time. Because now I know it works, I can now mount these, 4 of them, in some lovely, beautifully complicated design, and, even more excitingly, have all sorts of adjusters for each motor with the height, because obviously the higher it is, there's less of this to force across the string. So it would be handy to have the height adjustable and other bits and pieces, and that's because it doesn't matter where you pluck the strings, whether it's up here or down here. So I've got room to separate the motors, so that's even better still. I'm going to get on with that. But that is an extravaganza of joy. So 4 of them, I can even get it to strum if I play one after the other. It remembers which side it's on each time, so you just say, okay, I want to play that note. It'll then go back to the other side. Fabulous! Yes, we will go for a walk soon. Do you want to go for a walk? Yes, we will. Just give me a second. I can't stop now. I've just realised, of course. I've got the fingering carriage. I've got the plucking device. I can play some notes on it. I mean, it's ridiculous. Why not? So I've just added a couple of lines. I've written a little thing called pluck with a global variable just to remember which way to turn the motors on and off. So if whenever you call that, it just flips it around the other way. And it's as simple as this. It just goes through, it keeps 3 of the, I'm getting all excited, 3 of the frets in the same position, 0, and the last one, it just uses the I for the 4 next loop just to keep moving up to the top one, and then goes to pluck. Let's see what happens. Upload, right. That's ridiculous. Oh, I'm so pleased. It's doing it really quickly, and that's just one of 4. Look. That's amazing. Oh, that's crazy. I'm so pleased I thought to try that. Oh, right, drop everything and get on with designing the support for 4 of them. I can't wait. That is crap, that's absolutely nuts. Oh, it's a joy. Oh, God. Right, stop it, go get on, take the dog out. Ah.